Good evening, everyone. Thank you for joining us. Absolutely fantastic turnout, which is really good to see. So thank you. So as I'm sure you're aware, this is a CSCS and Chelmsford Civic Society co-production this evening, if you like. Chris Neal has very kindly put together this talk about the history of radar and RDF and his personal story, which, as I'm sure is the case for many people here, myself included, it's a bit of a personal story for a lot of people watching and listening this evening. I know a lot of people will have either first-hand or close family involvement in this. So it's a really, really interesting and pertinent topic. Unless Pam has anything she'd like to say on behalf of Chelmsford Civic Society, nod or shake, I suggest we make a start. Do you want to say anything, Pam?
I think go ahead, Adam.
So without further ado, I'll hand over to Chris. Thank you very much.
Good evening, everybody. I had intended to give a radar talk last year to mark the announcement of the Grade 2 listing of the World War II chain home tower sited in Great Baddow, which, if you've noticed, is a feature on the Chelmsford Civic Society's logo. A delay in the listing announcement and COVID scuppered that. It was also 100 years since my father was born. Without further ado, here is a story of radar. In November 1932, Baldwin made a speech in Parliament entitled "A Fear for the Future" and stated, "The bomber will always get through." The looming problem was that fast long-range bombers would be able to outpace our fighters, and the close proximity of our cities to Germany meant that we would have little time to get fighters in place to intercept them without mounting continuous standing patrols. By July 1934, events became more ominous as Hitler made himself Reich Chancellor of Germany. In August of that year, the British annual air exercises targeted the Air Ministry and the Houses of Parliament. More than 50% of the bombers got through and the Air Ministry was destroyed. Churchill stated, "London, the greatest target in the world, a kind of tremendous fat cow tied up to attract the beasts of prey." He demanded action. As a result, by January 1935, the Committee for the Scientific Survey of Air Defence was formed under Sir Henry Tizard to investigate all possible solutions. The committee asked Watson Watt about the feasibility of the death ray. He passed the task to his right-hand man, Arnold Wilkins, to calculate how much HF power was needed to raise 8 pints of water from 98 to 100 degrees Fahrenheit at a height of 1 kilometre, 5 kilometres from the transmitter. Answer: well, way beyond known technology. But he did calculate that you should be able to detect any reflective radio waves with their existing experimental receivers. 12th of February 1935. An excited Watson Watt sent a memo to CZAD, and probably the most important document in British radar history. I enclose herewith a memorandum on the detection of aircraft by radio methods. It turns out so favourably that I'm still nervous as to whether we have not got a power of 10 wrong, but even that would not be fatal. I have therefore thought it desirable to send you the memorandum immediately rather than to wait for close rechecking. The most attractive scheme is that of setting up zones of shortwave radio illumination through which approaching craft must fly. Air Marshal Dowding was approached for £10,000 to develop the concept into hardware, but requested that the basic calculations should first be tested by experiment. Within 2 weeks, Arnold Wilkins carried out the Daventry Experiment, the same day that Hitler announced the formation of the Luftwaffe under Goering. The reason for choosing Daventry for the experiment was to utilise the Empire Service beam station, a permanent source of high-power shortwave radio waves which would provide the necessary zone of shortwave radio illumination proposed in the memorandum. Using this painting by Roy Huxley, based on Arnold Wilkins' own recollections, you will see that he has set up dipole aerials on the ground to detect the shortwave radiation from the transmitter and any reflections from the Hayford bomber flying back and forth. Shortwave was thought to be necessary as its wavelength was twice the wingspan of the aircraft, ideal for resonance to give a stronger echo. The receiver was set up to have a stationary spot on the CRT where there were no reflections. Any reflections from the moving aircraft would move in and out of phase with the main transmitter and would result in the spot jumping up and down. Reflections were detected out to about 8 miles, enough to prove the principle. This experiment would only tell you that there was a moving object in the sky. There was no range information as the radio waves were continuous and not pulsed to give a time out and back. Pulsing such a powerful transmitter was a challenge to be met, as was the means to give bearing and height. Also, a way to prevent high-power pulses from overwhelming the sensitive receiver would need to be devised. There is the mobile lab, a converted Morris ambulance, and that's Watson Watt pointing at the CRT on the receiver which was inside that ambulance. And here is a picture of the original receiver which can be seen in the Science Museum. The success of the Daventry experiment released Dowding's Air Ministry 10K to develop the concept into a deployable system, and subsequent events moved very fast. On the 1st of March 1935, Watson Watt visited and approved the Orford Ness former World War I bombing range for the development work. The cover was that this was to be a station for ionospheric research, and he would be the superintendent. The secret system would be known as RDF, Radio Direction Finding, implying detection of radio emitters, not radio reflection. Development moved on apace. By July, detection range reached 40 miles with a 75-foot transmitter tower. And by November, solutions to measure the target's bearing and angle of elevation were found following Watson Watt's flash of inspiration on the train from Liverpool Street Station to Ipswich. Use a goniometer, a technique already in use to track lightning. By March 36, the range was improved to 75 miles using a newly built 240-foot tower. With facilities at Orford Ness being stretched to the limit, Bawdsey Manor was acquired and became the main RDF development site. The expanding team borrowed from government labs, universities and wireless manufacturers worked on many new RDF concepts, but initially focused on what became the AMES, or Air Ministry Experimental Station, Type 1 RDF, for long-range floodlit aircraft detection out to over 100 miles, and the beginnings of the chain of RDFs to protect the approaches to London and eventually most of the British Isles. And this is Bawdsey Manor with its aerials. With the outbreak of war, the research and development activities were moved from Bawdsey via University College Dundee to Swanage in Dorset to escape the risk of being attacked. In due course, the Swanage site became TRE and then moved to Malvern to escape attack. Post-war, TRE became RRE. This is the basic RDF station operating setup. Top left, you will see 4 360-foot steel towers, later stations had 3, with antennas strung between each tower to radiate pulses of shortwave radio waves from the transmitter out to over 100 miles. The reflected radio waves are sensed by dipole aerials mounted on 4 240-foot wooden towers and are sent to the receiver equipment to be displayed as traces on a cathode ray tube. This diagram shows the 360-foot steel transmitter towers with the curtain antenna array strung between them and the high power 30 MHz, which is 10 meters wavelength, pulse transmitter. The antennas produce a floodlight of radio waves, as shown in this polar diagram, out across the sea. The curtain array was designed and manufactured by the Marconi company in Chelmsford, and the transmitters by Metropolitan Vickers. Reflected radio pulses or signals are sensed by dipole aerials on the 240-foot wooden towers and are processed by the receiver, manufactured by AC Cosa, to form traces on the cathode ray tube. The further away the target is, the longer the reflected pulse takes to return, and so the distance along the x-axis of the CRT indicates the target's range against range marks on the tube. This polar diagram shows the sensing zones, or lobes, of the receiver dipoles. These are the means to estimate the target's bearing, or azimuth, as different positions in the lobes will affect the level of sensed reflections. The goniometer technique interprets these. The target's bearing is obtained by swinging the goniometer. This compares the signal strength from a pair of cross dipoles, and this will change as the gonio is manually rotated around 360 degrees, whilst watching the tube and noting the gonio positions, which give the maximum and, if possible, minimum pulse height on the tube. The maximum would give actual bearing, whereas the minimum would be plus 90 degrees, but is preferred as this is a sharper response. This diagram shows the wooden receiver tower in more detail, and a further set of dipoles used to determine the target's height. The technique is just as described for obtaining bearings using the gonio and tube, except that these dipoles sense the angle of elevation of the target. You will notice that the vertical polar diagram of the floodlight has gaps in which aircraft could briefly hide. So these are filled by extra transmitter antenna elements known as gap fillers. But there still remains a vulnerability, as the polar diagram shows limited low-level cover which could be exploited. The solution to this later. As a World War I pilot, Sir Henry Tizard knew that even if RDF location of an enemy plane was achievable, it would still be necessary for the defending pilot to be guided to the right location, both in terms of space, time, and strategic advantage. He instigated a number of trials at Biggin Hill to allow pilots to become familiar with the idea of being controlled from the ground, and for controllers to develop the necessary special skills. By September 1938, Chamberlain signed the Munich Agreement with Hitler and declares peace in our time. Unbeknownst to the Germans, Bawdsey was able to track his aircraft out and back from Munich. My mother, June, 15 years old at the time, worried in a school essay, "I wonder if there will ever be another great crisis in our lives quite as that of September the 30th, 1938. For weeks we had been hoping but fearing that the critical situation would not lead to war. Hitler's ultimatum cut our wondering short. In a week we should know one way or another. Slowly the days of preparation passed. ARP lectures and the fitting of gas masks, arrangements for children and working in offices with diminished staff. Hopes rose when Mr. Chamberlain went to meet Herr Hitler in Germany, only to crash again on his return. Everyone was prepared to do his or her part. Reserves were being called up, extra police, men enlisting. This sudden knowledge that 100 new Navy vessels were waiting to be launched brought England to the eve of war. Just 3.5 years after first imagining the concept of RDF, 5 CH stations, estuary chain, Bawdsey to Dover, go on full 24-hour watch. And there is the Bawdsey CH station with its full complement of towers. 1939, a further 15 CH stations extending from the Orkneys to the Isle of Wight go on full 24-hour watch and will remain so for the entirety of the war. Achievement of this timely milestone was certainly helped by those few extra months of peace brought by Chamberlain's Munich signature. This map shows the locations of the operational stations at the outbreak of war on the 1st of September 1939. This map shows the coverage at 15,000 feet that they provided. Note that RAF Hillhead was not operational in time, leaving a gap along part of the Scottish coast. As explained earlier, CH was fundamentally not able to provide adequate low-level coverage, temporarily leaving an opportunity for low-flying invaders to escape detection. The problem was solved by deploying a War Office RDF set known as CD, Coastal Defence, designed to spot offshore surface vessels, and modifying it to track low-flying aircraft. This became the Amy's Type 2 CHL, Chain Home Low, and its concept proved to be the precursor of most modern radars. Now this is recognisably a radar, rather than a wireless broadcast station, and it operates on the radio lighthouse principle as opposed to floodlighting as per CH. The relative compactness of the Amy's Type 2 was made possible by the development of high frequency, high power pulse transmitter valves. The shorter wavelength of 1.5 metres enabled an antenna configuration of just a few metres. This gave the opportunity to rotate the antenna to point at a target, no more gonios, which initially was a manual process. But the development of rotating waveguides made it possible to continuously rotate the aerial, allowing a full 360-degree scan of the skies. The co-location of transmit antenna and receive aerials required a means to stop the high-power transmitter blowing up the sensitive receiver electronics. Development of the TR cell solved this problem. It has to be said that these basic elements have formed the blueprint for most post-war surveillance radars up to the advent of high-power solid-state electronics. The rotating antenna is mimicked on a circular CRT screen configured such that the centre is the point of rotation of a scan, which will show bright echoes dictated by the target's range and bearing. This form of display is referred to as PPI, Planned Position Indicator. So much easier than the laborious process needed to obtain range and bearing in the CH system. For increased accuracy of range, the system nevertheless retains the A-scope trace seen on the left of this diagram. This is the operator's console used in the CHL system, with the A-scope and PPI clearly visible. In locations lacking adequate high ground, CHL would be mounted on a standalone tower, this is Hopton in Suffolk, or on a CH tower gantry. This map shows that by July 1940, 10 additional CH stations and now 27 CHL stations were added to the home chain. The results of this expansion, especially the deployment of CHL, show the comprehensiveness of coverage by 1941. February 1940. Bruce Neal, just on his 20th birthday, a Southend Corporation Electricity Department clerical worker and self-confessed wireless enthusiast, enlisted in the RAF as a Class F reservist. His family were well aware of the implications of service in the armed forces. His father had been a private in the King's Royal Rifles and had been in action on the Somme and Passchendaele and was wounded in each of those battles. He died in 1931, said to have been from the effects of being gassed, leaving Bruce to be the family breadwinner for his mother, grandmother, brother and sister. A promising start as a scholarship boy at Kilburn Grammar School had to be abandoned. March 1940. RAF trade test. His hobby interest made him a candidate for a technical role in the RAF, and he would have been asked, wireless or radio. Anecdotal references to this process suggest that the questioners had no idea what the difference was, and is not surprising. Wireless meant communications, and radio meant RDF, a state secret. Bruce must have chosen radio, was ranked as a leading aircraftman mechanic, and, seemingly based solely on his home-built wireless experience and no formal RAF technical training, was posted to RAF Netherbutton CH station in the Orkney Islands. Netherbutton, the UK's most northerly RDF station and guardian of Scapa Flow, the Royal Navy's main base in World War II. The base had been attacked by German bombers shortly after the declaration of war. The CH station at that time was made up from various pieces of prototype equipment from Bordsey, and its performance and reliability was poor. That's the view across to Scapa Flow from the RAF Netherbutton site. Bruce arrived soon after new 360-foot steel towers were built. Their configuration, with the two end towers being set at right angles to the middle pair, was unique and necessary for the island location to provide a semicircular view of the sky. Bruce relaxing on a dry stone wall. Little was he to know then, but he would spend much of his career in the shadow of a CH tower at Great Baddow. He was billeted on the local farm with the farmer's family, and here the chance for a bit of agricultural R&R. So what was he responsible for as a mechanic with hobby wireless experience? Basically, as part of a team, commissioning, calibrating and maintaining the transmitters. CH stations had two transmitters. The transmitters were based on extensively modified shortwave beam transmitters in order to generate regular, rapid, well-shaped pulses with minimal power radiated between pulses when compared with the receiver sensitivity. This is a West Coast transmitter with its covers off, and here's the RF power section. The RF power was generated in a master oscillator at half the operating frequency, then amplified and doubled in frequency in a driver stage, then amplified to full power by a pair of tetrodes in push-pull. The driver and the two output valves were water-cooled and demountable, continuously evacuated by oil vapour vacuum pumps. These are the valves. They were cooled and anode transmitter valves. The anodes being so heavy as to require a chain hoist for lifting to allow the valve filament to be replaced. The filament began life as a 5mm diameter hairpin of thoriated tungsten, 30 centimetres long, and ended its life when it became so thin as to fracture under vibration. The filaments consumed up to 5.5 kilowatts for each output valve, and as a standby transmitter ran with hot filaments, a total of 30 kilowatts to provide 200 watts RF. Less than 0.5% efficient. May 1940. Churchill succeeds Neville Chamberlain as British Prime Minister. July was the start of the Luftwaffe campaign to destroy the RAF ahead of an invasion of the British Isles in what became known as the Battle of Britain. Finally, by October, the Battle of Britain was won. RAF Fighter Command had been stretched to the limit and probably could not have sustained the level of activity and attrition for much longer. Air Chief Marshal Lord Dowding, Commander-in-Chief of Fighter Command, said of the radar air warning system, the warnings it gave could have been obtained by no other means and constituted a vital factor in the air defence of Great Britain. With risk of invasion now averted, critical radar resources could be freed up to bolster the defence of our overseas territories. By November, Bruce, newly promoted to corporal, boarded Her Majesty's troopship Viceroy of India in the Clyde, bound for the Middle East and eventually Aden in the Yemen. This will be a 6-week voyage in convoy WS-4B bound for Cairo. WS, or Winston Special Troop Convoys, were instigated soon after he became PM and transported thousands of troops to the Middle East and elsewhere. Bruce recalled the time when the convoy reached the Gulf of Aden. Christmas Day 1940. We had been at sea for over 6 weeks and had emerged unscathed in spite of the ridiculous claims of the German High Command that they rule the sea. But now we were really faced with a test. The passing of this very large convoy of 10 troopships from the Gulf of Aden through the narrow strait into the Red Sea within walking distance of Italian territory. Were we heading into a trap? A fleet of waiting submarines or a squadron of dive bombers. It seemed impossible that the Gestapo or the activity of the Fifth Column should be unaware of our existence. Information surely must have been collected at Freetown or Durban, which doubtless were infested with foreign agents. Our speed had been reduced to 8 knots when we entered the Gulf, presumably to enable the convoy to pass through the straits under the cover of darkness. Our naval escort had been considerably strengthened by a light cruiser of the C-class and 2 destroyers from the Mediterranean fleet, which, together with escorting cruisers and our own 6-inch guns, we could have put up a very good show. To our port, the rugged coastline of Italian Somaliland. Any moment now, surely we were spotted. The troops, well fortified with an excellent Christmas dinner, were in good spirits. It was now almost dark. The little islands dotted all around us, the dark, ominous outline of Somaliland, the destroyers shooting in and out, the zoom of an occasional friendly aircraft, the formidable outline of the escorting cruisers ready for anything, the thousands of cheerful but slightly anxious faces which lined the decks, provided one of the most inspiring spectacles I have ever known. Darkness had now fallen. Full speed ahead. I knew we had made it. January 1941, he arrived in Aden to join Amy's 506. His tour of the Middle East is to last until May 1944. And just to underline the hazards of seafaring in wartime and the lack of information that families had on the whereabouts of their kith and kin, this letter, salved from the sea, from his brother, was posted to CO Army Post Office 725 on the 17th of January, the day after his arrival in Aden, and it's not known when he received it. January 1941. The Amy's 506 mission was to build and operate a version of CHL called COL, Chain Overseas Low, to provide airspace surveillance for the port of Aden and approaches to the Red Sea. The site selected was Ras Marshag, or Steamer Point, the location of a working lighthouse built by the British in 1866 and situated 100 feet above sea level. Time was of the essence in anticipation of British plans to retake British Somaliland from the Italians just 150 miles across the Gulf of Aden. Bruce recalls, "We were under constant surveillance by the Italians. The day the RDF went operational, without test or trial, an agitated native bearer reported an enemy aircraft overhead. The RDF had seen nothing. A Gladiator was scrambled, vectored on a course indicated by the bearer, and made a perfect interception. The Savoia Marchetti 19 was shot down, and the success attributed to the new Magic RDF. But honesty prevailed. The station log recorded 18:30 hours, native bearer Ul Mohammed reports hostile aircraft overhead. We found the SM-19 floating in the Gulf. It was made of wood and stuffed with Italian generals. They were highly indignant that we'd shot them down, as they were only on reconnaissance. There may not have been any bombs on board, but there was a crate of Chianti in danger of sinking, so we rescued it, and, together with the generals, passed a happy evening toasting Winston Churchill, Benito Mussolini, and King George VI. War seemed a long way away. By March 1941, the British executed Operation Appearance from Aden and retook British Somaliland. By May, the entire Italian East African regime surrendered to the British. Between 1943 and 44, Bruce moved on to various RDF sites in Egypt, certainly Port Said and Alexandria, building an RDF on the base of the ancient Pharos, and also mentioned RDF on pyramids. I need access to Amy's 531 and 581 operational records in the National Archives queue, currently closed for COVID, to unravel all of these activities further. Summer 1941. Fresh from a short course at Eastbourne Catering College after boarding school, June, having reached her 18th birthday, visited the Air Ministry at Adastral House, the location of Tizard's CSAD committee, in London, and enlisted in the Women's Auxiliary Air Force. She had hoped to join the Navy, but they were not recruiting Wrens at that time. Her family would have known the implications of that decision to enlist in the armed forces. Her father had been a captain in the Royal Horse Artillery and had been in action in Ypres and Passchendaele. He received a Blighty wound just 24 days before the armistice, when he attempted to fire the German howitzer he had captured. The gun just exploded. In August, June was posted to RAF Bridgnorth and the recently established No. 1 WAF depot for initial military training. In September, she is posted at RAF Yatesbury for a 6-week operational training course. It is likely that it was here that she would have been asked that question, wireless or radio. She emerged as a radio operator, having been initiated into the RDF secret and the means of detecting aircraft in flight. Arthur C. Clarke was a trainer at Yatesbury, but not known if June was trained by him. She is now qualified for the Amy's Type 1 RDF. The radio's operator's desk consisted of a CRT screen or tube, a goniometer, gonio, a keyboard, and a GPO operator type telephone headset. Their task was to watch the tube for targets out to over 100 miles. Skilled operators could often assess numbers of aircraft and even their possible type by the observation of subtle patterns within the displayed trace. When acquired, to measure their apparent range, bearing and vertical elevation by turning or swinging the gonio, the results of which would then be corrected to account for the Earth's radius, site contours and other calibration adjustments. The corrections were applied by an electromechanical calculator, the Fruit machine, which had been designed and built by GPO engineers based on telephone exchange technology. The resulting range and bearing would be transposed into grid coordinates, from which a true track would be plotted, and along with altitude above sea level, transposed from corrected angles of elevation, passed via GPO lines into the air defence network known as the Dowding system. October 1941, June's first operational posting was to RAF Hawks Tor CH station near Plympton, overlooking Plymouth and the western approaches. June recalled, "I was billeted in a 3-bed semi with a retired couple with Wren daughter and another married to a firefighter in Plymouth. She slept each night in Plympton with a bed in the dining room after the bombing of Plymouth when the whole city centre was flattened. A 4-watch system, with Commer van leaving Plympton some half hour before duty commenced. We were not allowed to sing on night transports as we disturbed the villages that we passed through. The OP's block was a wooden building surrounded by high walls of sandbags. When attacked by the Home Guard, the site was taken. The WAF loo, situated on the boundary, necessitating a conspicuous long walk. A watch consisted of an officer, NCO, 5 to 6 operators, 2 to 3 mechanics RAF. Each position was held for an hour, the sequence continuing from watch to watch. The tube operator gave range, bearing and height, and later IFF. The plotter worked out the grid refs on a map covered with perspex with a crayon and passed the plot to the filter room. Operators wore headsets who gave the plot track, identity, hostile number or friendly. The recorder kept written notes of all plots. The officer and NCO each wrote a watch report. A 4-watch system was worked, 3 times 5-hour shifts and a 9-hour overnight shift. This is Hawks Tor site today. Concrete foundation blocks for one of the masts, and gives a good idea of how bleak the radar stations could be. And this is a Google Earth view. Many of the World War II radar sites can be spotted this way. Spring 1942. After 6 months at RAF Hawks Tor and promotion to leading aircraft woman, June is posted to RAF High Street, Darsham, Suffolk, an East Coast CH station. By November, she's back at RAF Yatesbury for a 6-week radio operator mechanics course to be qualified for CHL and promotion to corporal. December sees her posted back to the East Coast, this time to RAF Hopton in Suffolk, that same CHL station that I showed the picture of earlier. Early 1943, she's promoted to Flight Sergeant. She's then posted to Malvern College, the new home of TRE, which had moved from Worth to Travers, Swanage, for training on the newly TRE developed and top secret Amy's Type 9000 oboe precision blind bombing navigation system. This is when June's role crossed from defence to offence, and she recalled, "First, we were asked if we had any moral objection to being directly involved in bombing Germany, to which she must have said no." Air navigation at the beginning of World War II was very basic, relying on the stars, dead reckoning, visual sightings and some elementary radio aids which were easily jammed. As a consequence, the success rate of bombers hitting strategic targets at night after flying 200 plus miles were dismal. Analysis of bombing effectiveness over the first 2 years showed that less than 10% of all bombs dropped on the Ruhr fell within a 5-mile radius of the aiming point, and probably less than 50% within 25 miles. Because of the industrial haze that normally enshrouds the Ruhr Valley, Essen, the armament centre of Germany, including the giant Krupp's works, emerged virtually unscathed despite the regular attention of Bomber Command. Yet bombing was considered by Churchill to be the only practical way of crippling the German war machine, despite the cost in Allied lives and materiel. Major improvements were operationally, the formation of the Pathfinder Force, new aircraft, the de Havilland Mosquito and the Avro Lancaster, improved target markers, coloured flares with precise ballistic characteristics for ground and sky marking, and of course the development of radar navigational aids, G7000, Oboe 9000 and H2S. Plus, of course, the courage, skill and dedication of the Airmen of Bomber Command, which became a major contributor to the ultimate defeat of Hitler's Germany. Oboe was a target marking system ground controlled from the UK. It had a minimal theoretical error of plus or minus 17 yards when the target marker was dropped from a height of over 32,000 feet out to a range of over 250 miles from the ground stations, the range limit being just beyond the ground station radar horizon. The target markers laid by Pathfinder Mosquitoes fitted with Oboe transceiver units achieved consistent accuracies of between 50 and 100 yards, and in many cases were within 30 yards of the aiming point, enabling the heavies to follow up with 4,000-pound cookies, 12,000-pound tall boys and 22,000-pound grand slams with deadly consequences. The system requires radio beams from a widely spaced pair of transmitter receivers able to sweep the zone of the distant target. Krupp's factories around Essen were targeted from RAF Winterton in Norfolk and RAF Kingsdown or Hawks Hill near Dover. Winterton was the cat, sending out coded signals to the Pathfinder aircraft to keep it flying along a circular track which would pass over the target. The pilot would have received dots or dashes in his headphones that would tell him to steer left or right. A constant sound indicated dead centre of track. The other station, Hawks Hill, was mouse and would have turned its antenna directly to a point before the target, which would have been calculated to be the point at which the specific target marker type would need to be dropped from a prescribed height to hit the target. The navigator would have received a coded dot-dash signal to release his target marker. The main bomber force then followed up and bombed the target marker. Early trials of the system used CHL radars, but the wavelength of 1.5 meters was too long for high accuracy. With development of the magnetron, high-power RF was now available at 10 centimeters S-band, and that became the standard for the Oboe system, allowing small transmit and receive dishes, leading to fully mobile units that were eventually deployed in mainland Europe after the D-Day landings. And that's Oboe Mark III's S-band radar dishes at RAF Winterton, and you can see how small and rotatable those dishes are. That's the Oboe control console, 2 CRTs, one for monitoring cat signals and the other for mouse signals. And this is Pathfinder Mosquito F for Freddy, marking its 204th mission. And finally on this set, there's the Oboe airborne transceiver equipment, a pretty crowded cockpit. This is a list of principal Oboe stations and show how they were paired depending on the locations of the intended targets. And indeed in spring 1943 June was posted to RAF Trimmingham and RAF Winterton in Norfolk, and then early in 1944 to RAF Hawks Hill Down in Kent. 6th of June, D-Day. This finds June at Worth-Matravers, right across the water from the landing beaches, and would be assisting the targeting of strategic German assets in support of the invasion. The 13th of June saw the start of the German V1 Vengeance campaign and the RAF hunt for their launch sites, factories and storage facilities. 4th of July to the 7th of July, the V1 storage facilities in limestone caves at Saint-Louis-de-Saron in France were hit by oboe-guided bombs which destroyed the entrances to the caves. And on the 5th of August 1944, oboe-guided RAF destruction of U-boat pens, Brest, France. And this is what a £12,000 tall boy could do. October 1944, and June's back in RAF Hawks Hill Down. After 3 years in the Middle East, AMES 506 in Aden, AMES 531 Port Said, and AMES 581 somewhere in Egypt, Flight Sergeant Bruce Neal returns to the UK and is posted to RAF Hopton CHL in time to support efforts for D-Day. That period would have been extremely busy for all of the country's radar stations, both defensive and offensive. September, he's posted to RAF Yatesbury, No. 9 Radio School, for a course on oboe, and promotion to warrant officer. This is a later picture, the suntan has worn off. October, posted to RAF Hawks Hill Down oboe station. Family history is made. June recalled, posted to RAF Hawks Hill Down, Kent, with a group of oboe WAFs, as Worth-Matravers was doing little work by then. We were put into a large, leaking, empty house on the Dover Road with a bed, mat, chair each, and a wardrobe and dressing table shared. There was a boiler, coke, which we were supposed to be able to keep going, but it was quite impossible. There was no heat in the house unless anyone managed to light a fire in their grate, not easy with coke. It was a very cold winter, and I was lucky to be warmed and well fed in the sergeant's mess, where there was an abundance of scalding water for baths. A skinny, worn-up brown warrant officer arrived at the mess, fresh from the Middle East about this time. Early in 1945, June and Bruce are separately posted to RAF Winterton in Norfolk. And during this time, oboe is used to guide bombers to drop food parcels in precise locations to relieve starving Dutch civilians who were still to be liberated. Post-war, Bruce met one of the grateful recipients at a radar conference. RAF Winterton Oboe Station. These pictures look like publicity shots for the RAF, as there was no way that private cameras would have been allowed in such a secret establishment. It must have been taken after hostilities had ceased. It looks too relaxed. Top right is the operator's console with operators seated in front of the cat and mouse CRT displays. Top left is a similar console with the bottom CRT SASE being removed. Bottom right, a little R&R in the Nissen hut. And bottom left, Warrant Officer Bruce Neal with his hand on the transmitter. A busy shift, and There are Bruce and June discussing something important, maybe. I am sure that this is a fairly unique photograph, despite the large number of partnerships that resulted from RAF wartime service. May, Victory in Europe Day. June and Bruce could have been either in Hawkshill Down or Winterton, or who knows. In July, June is taken on a flight over Germany to view the remnants of some of the strategic targets that Obo had assisted in pinpointing. The pilots were extremely grateful for the work of the WAFs in safely guiding them to their target in very difficult circumstances. She was given the bomb aimer's position in the Lancaster, but spent most of the trip with her head in a sick bag. 15th of August 1945, Victory in Japan Day, and the secret of radar is made public in the UK and the US. The Ministry of Information published an authoritative account of the story of radio location. 80 foolscap pages of fascinating reading. By December, June is finally demobbed. Spring 1946. June and Bruce get married. Bruce's brother John, a second lieutenant in the Royal Navy and an MTB pilot, was their best man. By May, Bruce is finally demobbed. 1947. My Mother and I. To be followed in due course by a sister and 2 brothers. By way of a postscript, this is Bruce presenting a painting of the Daventry Experiment that you saw earlier to Arnold Wilkins. Arnold lived in Woodbridge, and June and Bruce got to know him and his wife quite well in the latter days of all their lives. The painting was based on a sketch by Arnold. And, at last, after previous abortive efforts, the last remaining complete CH tower has been listed. Thank you for listening and viewing.